My name is Sandra Muhammad Iwas, and for my curve sketching teaching for my Calc final, I'm choosing this equation. All right, so for this equation, the first thing you do is you find the first derivative. So if you just zoom in a bit, that way we get more space. There'll be f prime, so it'll be 1/3, and then the derivative of x cubed would be 3x squared. Derivative of x squared would be negative 2x. Derivative of negative 3x would be just 3. And 4, since it's a constant, just be 0. And then, so for this, the 1/3 times 3, these guys just cancel out. So then that just leaves you these guys with the x squared minus 2x minus 3. So if you just write it again just a bit more clearly, so that'll be x squared minus 2x minus 3. Okay, and then for this, we're going to find the minimum points real quick, algebraically. So for that, you would just take negative 3, multiply it by x squared, so it'll be negative 3x squared, over negative 2x. And it's going to ask, so what two numbers would multiply to negative 3x and then subtract to negative 2x? So it'll be negative 3 and then negative 1. And then so you write it down as x minus 3 and x plus 1. Okay, so we have our let's see, we have our maximum and our minimum. Alright, so then we do our second derivative to get, oh, sorry about that. Then we do a second derivative, so this will be 2x. X squared will, derivative x squared will be 2x as you use the power rule to bring over the 2. And then you subtract it by 1, so that'll be just 2x. And derivative of x is just, you just bring over the 1. So 1 to 0, you just get rid of the x. And negative 2 times 1 is just negative 2. All right. So from here, right. So now that we have the maximum minimum, we would know, so if we do the number line, and we would plot these guys out, so that'll be, let's see, here, negative 1, and then negative 3. So it'll be positive, negative, positive. Alright, so from this, we would know that so since this is the minimum, we would know that it would come in decreasing. Alright, so we know that from here, the function, if we graph it, it will be increasing and then decreasing. So it'll most likely be, oh, sorry about that. Ooh, my mistake. Just caught it. It's the other way around. Sorry about that. That looked weird. Alright, so that's the minimum and the maximum. Alright, so the way you notice the minimum is, it would, right? Yeah. So this will be increasing, all right, and then it'll get to a point where it'll reach the max, so it can't increase anymore. So this will be a max at negative 1. So this is our max, and then it'll just decrease from there because it's reached the max, the local max or the local extrema. And then as it gets to negative 3, it's the lowest. So, and the way we know it's the minimum is because from there it'll start increasing. So it starts from decreasing and then it goes into increasing. So it'll be the minimum. And also this is where the function is decreasing. So at negative 1, it's where it's decreasing, and at negative 3, that's where it's increasing. Because it goes from here and it goes increasing to positive. All right, and then so because of that, so now we know what's increasing and decreasing at with the first derivative, and with the second derivative. So if you do the second derivative, you would so we found the first derivative. So if you would take out the 2, factor out the 2, you would get 2 over x minus 1. So this means that so if you do a number line again, oops, sorry about that. Come on, no, okay. Sorry, technical issues. So if you would get a number line, and then you would put 1 because of here, you would anything that's below 1, so anything that is lower than 1, so if it's higher than 1, it's positive. If it's lower than 1, then it's negative. So it'll be here, here. So if you would take this into account, that means if it's a negative, it will concave down. If it's a positive, it will concave up. So if you were to graph the equation, oh, sorry about that. My hand's kind of getting tired from holding it. All right. Oops, sorry. There we go. That's in there, and then let's go here. Oh, some of that. Yeah. Okay, and then you go here, and then you would. Okay, so now that we have our equation, we have both the derivatives. We know there'll be a concave down and a concave up, and then there'll be an inflection point at 1. We also know the maximum and minimums, right? And then so we start graphing it. So if we would plug it into, so then the 0 would be at, let's see here. So we know it has a y-intercept of 4 because of this value, so it'll be at 1, 2, 3, 4. So here will be y-intercepts, and then we know we'll have a point at -1, because that's the maximum, and we plan a point at, let's see, at 3. So that's 1, 2, 3, 4. Oh, sorry. I should have labeled it first. My bad. Okay, so it'll be 1, 2, 3. Sorry, bear with me. 4, 5, 6, 7, 8, 9, 10. It'll be 1, 2, 3, 4, 5, 6, 7, 8. That should be enough. 1. That's a bit too far. 1, 2, 3. Oh, it'll be -1, -2, -3, -4, -5, -6, -7, and -8. Ooh, must be -1, -2, -3, -4, -5, and -6, 7, and 8. All right, cool. So we have a graph. So we know there'll be a y-intercept at 4. Let me use a different color. There'll be a y-intercept at 4. And if you were to grab it and plug it into decimals, you would get a point at -1, 5.667. So it'll be here. And you get one at negative. Yeah, and then you get another one at -3. All right, 3, -5. So this one will be around here. Let's start with that. All right, and then you get your x-intercepts at, so you'll be at 1 at a little bit past that 1 point, right? So it'll be a little over here, and there'll be another one at a little past 4, so we'll be at 4, 4. So I spaced them out a little bit more. And then there'll be another one at -2.5. And then if you just, let's see here, if you would just combine them, something like that. Here, oh, silly, something like, please forgive my horrible graph. I'm so sorry, I butchered it. Oh, okay, so yeah, it'll be something like that. So, like I said, with the second derivative, anything less than 1, the inflection point. So 1 is the inflection point. So then that would mean that, see, if it was less than 1, it's concave down. Higher than 1 is concave up. So, yeah, so then, and then this point would be, use blue, the maximum, because it's the highest, or local maximum, because it's the highest point. This will be local, let's be the local minimum, because it's the lowest point. Just local minimum, mini. And then, and see here, it's increasing. I'll use a highlighter. It's increasing, and then it's also decreasing. So it gets the highest point and goes down, so it's decreasing. And then this one's sorry, wrong one. It's decreasing. So when it decreases, it reaches the lowest point or rock bottom, and it starts going up because it hits the lowest point. And then this is also the point of inflection, because this is when the second derivative flips from a negative to a positive. Thus, so thus the flip. And so there's a point. So if you were to write it out, so we'll have intercept roughly at, so oops, sorry, never at other side. Intercept at -2. Oh, sorry. So the intercept will be at -2.5, and then it'll also be at 1, 0, which is 1, and then also at 4.5-ish. And then, so this is for the x-intercepts, x. And for the y-intercepts, oops, sorry about that. Y-intercept, it's at 4. And let me use a different color to accentuate it, too. Let's use purple. So there we go. I don't know if you can see that clearly. So that's the intercept. So then you'd be at, oh, sorry about that. So the y-intercept would be at 4. All right, and then our local max would be at -1, comma 5. This here, it'll be -1, comma 5.6. And then our local minimum would be at 3, comma 5, or -5. And then for the derivative, it'll have a concave up from, oh, it's right here. I'll have a concave, my mistake, jumping ahead. Concave down, so I'm talking about this point right here. This one right here. I'll have a concave down of, starting from, let's see, what was this? Negative, let's see, -2.5, also it'll be negative infinity, and then it reaches to -1, -1 to the inflection point, which is 1. So that'll be the concave down, and the concave up would be from, let's see, 1, comma, be 3, so that's 1, comma 3, to 3, comma infinity, because it goes up. So these are the two concaves. This is in the point of inflection. Point of inflection. Oops, sorry about that. Would be 1, comma 0. So that's got the maximum, minimum, point of inflection, the concaves, and that about wraps it up. Yeah, that's about it. We have the first derivative and the second derivative, minimums and maximums. Yeah, all right, that concludes it. Thank you for coming to my little lesson.